This video will cover the oxidation of alcohols using bleach. Bleach is hypochlorous acid. The structures of these compounds look like this. In both cases, chlorine acts as the electron acceptor, or the oxidant, for the oxidation process. Bleach oxidizes primary alcohols to the carboxylic acid and secondary alcohols to the ketone. Now let's look at the mechanism. The mechanism for the oxidation with bleach of a secondary alcohol starts by protonation of the alcohol using the hypochlorous acid. This converts the alcohol to a good leaving group and also gives us the hypochlorite anion, which is a good nucleophile. In the next step, the hypochlorite attacks the alcohol, kicking off water. In the final step, the water that's formed deprotonates, oxidizing the alcohol and reducing the chlorine. The process for oxidizing a primary alcohol with bleach looks very much the same as the mechanism for oxidizing a secondary alcohol. However, since we oxidize the primary alcohol up to the carboxylic acid, we're adding an extra oxygen, and so there's an extra set of steps for that oxidation process. Basically, it follows the mechanism for the secondary alcohol twice. Just like with the secondary alcohol, the first step of the mechanism involves protonating the alcohol. The hypochlorite then attacks, kicking off water. Finally, water deprotonates, oxidizing the alcohol and reducing the chlorine. This produces the aldehyde intermediate, but because the carbon bound to the oxygen contains another hydrogen, this compound can be oxidized even further. Oxidation does not happen directly to the aldehyde, but to the hydrate of the aldehyde. To hydrate the aldehyde, the first step is to protonate it. The protonated aldehyde can then react with water to form the hydrate. The protonated hydrate is then deprotonated by another molecule of water. This hydrate then reacts with another molecule of bleach, first protonating the alcohol, and then by attack of the hypochlorite. In the final step, water deprotonates, oxidizing the oxygen and reducing the chlorine, which produces the carboxylic acid.